I work as a cloud architect, which sounds really silly, but I facilitate architecture in an organization, which means working with other developers as peers to develop architecture and then come up with best practices for how we want to be engineers, test things, and choose the tools that we want to work with. Sparefoot is a medium-sized development, or we have a medium-sized development team. We have a lot of developers. We run about 1,000 containers. And we have a very small DevOps team of just 2. Most of it's powered by Chatops. Our philosophy is just empower the developers as much as possible to be self-service so that if something breaks, they can go fix it. And a lot of this talk is going to be about how you can enable your developers to go self-service with Lambda if you choose to use it as a tool in your tool set. All right, so I'm going to be talking about a couple terms. They're very AWS-centric. If you know these ones a little bit, you'll be good for the rest of the talk. The AWS CLI is the command line tool that you can interact with pretty much all the AWS services that you run on the command prompt. That uses AWS credentials to authenticate, and you can have multiple sets of AWS credentials installed on your machine. You specify the profile, so this lets you interact with your Amazon cloud as a different user, and that's going to be really important later when we want to interact as a Lambda user with a different permission set to make sure that we actually have permission to act as a Lambda to consume the resources we need to. EC2 is Elastic Cloud Compute. That's just your standard servers, I think, the most ubiquitous of what we use today on AWS. IAM that's how we manage identity and access management in AWS. It's a pretty complicated topic. I'm going to just cover the bare minimum of what we need to test Lambda. ACL is a complicated subject no matter what platform you're on. And then continuous integration, and this is, you should be familiar with, or hopefully, if not, welcome to the party. That's running our tests every time we check in. Okay, so Lambda in a nutshell is this neat little EC2 timeshare that you can run stuff on. It is, when I say it's tightly coupled to Amazon, it means you can't just be like, well, I'm going to substitute Google's cloud service. There's a lot of very AWS-specific things that don't make it a good candidate to just sub out with a different service. But at the same time, it's also very highly integrated, so the plumbing is really good between Lambda and other services. So if I need to do a proof of concept, I can usually knock it out in just a few minutes, where it would take much longer to plumb in, oh, I need to connect to SQS, or I need to subscribe to the event stream for S3 every time an object gets dropped in an S3 bucket. It would be much harder to do if it wasn't just the way they built the platform. It's very ingrained with the plumbing. It is stateless execution, which means every time you bring it up, like there's nothing there from the last time that you ran on the instance that's running your code. That doesn't mean your application has to be stateless. It just means the local environment isn't going to have something like sessions. They don't exist. So you can't have a user sign in and keep a cookie between page requests if you're using API gateway to power it. It's just not going to be there every time it comes up. But you can put records into your database, get your state from the database or some other form of persistence, and continue execution. So if you're doing complicated computing, you can have, as long as you can break it down to a small piece of work, Lambda can do it for you. The things that I think are really great are for AWS-specific kind of DevOps tasks. We use it for, we run essentially a cron that heals all the database permissions like once an hour. We watch IAM. Anytime someone makes a new IAM account, we'll get an email with essentially what changed, mailed to everyone on the DevOps team. We also use it in facilitating our developers. Every developer at Sparefoot gets root access to our sandbox account and can set up any infrastructure they want in the account to build a proof of concept. But the Lambdas will tear down after about a week based on how they tag it. So we don't have to worry about paying for bills for compute resources they've set up and forgotten about. So it's just another little, this makes it really easy to let developers go do something, but then I don't have to go watch over my back and make sure I'm not going to get a huge bill. So this is kind of the event cycle of what happens on Amazon side when a Lambda gets executed. Some event is the entry point that comes into the application, and that gets put into an event queue. And I don't know if it's SNS or something more specific. It could also be something like their Kinesis. But essentially, something then pulls that record out of the queue and tells it to go launch on an available Lambda instance with your code and process it. And if it's successful, it takes it out of the queue, just normal queue processing. But this all happens transparent to the way we interact with it, but this is what's happening underneath. And then finally, we have a callback event with the response from our function or the failure event to call the Lambda that gets passed back to the entry point. Now, you don't always have a callback event. That's if you're using API gateway or you're calling from the command line. You're going to get a response. You're going to have that callback event happen. But if you're doing stream processing or something else, there isn't going to be really a callback event. You're just going to go right to persistent somewhere and move on. So it's a great tool, but it's not the tool for everything. It's better at small stuff that doesn't take a lot of CPU time. Real-time data pipelines, I think, are a good candidate where if you really want data in real time, you're going to go ahead and pay for it. But the other things, like a cron task, it may take 4 hours. You don't want to run a Lambda. You can't run a Lambda for longer than 300 seconds, but you wouldn't want the job to be executing 4 hours of Lambda time because it would get very expensive. It can be useful for microservices if you're just querying the database to provide some bit of information. You don't have to do any heavy processing. It may be worth wrapping up with an API gateway. It's great for queue processing, and in fact, that's how we orchestrate workloads between Lambdas. We will have a Lambda do part of a data pipeline, write an event to the queue, and then let another Lambda that's subscribed to that queue pick up that data point and do the next part of the pipeline so that we can decouple different parts of our application. Maybe we ship a bad version of a Lambda and we have invalid data from some step on. Well, we can just requeue all those events and have them pick up at that point by just pushing new SNS events in. Things that I don't think it's good at are things that need to run longer than 300 seconds. That's just not going to work. Dedicated computing, you're better off bringing up an EC2 and just letting it run. High traffic services, if you're going to need more than 100 concurrent in one region, you're going to need to contact Amazon to raise the limit because there's a concurrency limit, which makes me think, okay, not good for web tier by default, because if you have a rush on your site, you don't want your service to fail because you've gone over the concurrency limit. They can scale that up, I think, to 10,000. We never have, because we mostly do data pipelining. The other thing is it's not good for low traffic but performance services due to there's a preheating penalty. If you haven't used a Lambda for maybe a couple hours, the first time you spin it back up, it's going to take 2 seconds. Our customer SLA is we want the entire page delivered to the customer in 2 seconds, so that wouldn't leave us any processing time. So we generally don't do it where time is critical. So this is our, it washed out. This is an excerpt from our bill for, I think, July. And this is, we're actually a paid tiered customer for Lambda because they give you a free 1 million invocations a month. We only use 1.4 million, so our cost was 8 cents to use Lambda. I don't feel like we're holding back. We're using it everywhere we want to, and it's a great tool for what it is, so I guess it's a great value. They compute the billing in two ways. One is this thing called compute seconds. A compute second is like 1 second where you have the Lambda running with 128 megs, and you are allowed to scale up how much RAM your Lambda uses on every invocation. I think up to like maybe a gig. If you do that, you're using 10 invocations a second instead of 1, so you'll burn through this faster. But obviously, of 400,000, we only use 75,000, so we have a lot of space that we can use. We could go scale up probably all of our Lambdas to make them execute faster. And then the invocations, yeah, we did 1.4, so pretty cheap. So I think it's great for small tasks. It's not for everything. It's still not your heavy lifter for data processing. So I'm going to go a little more into the platform. I showed the event lifecycle, but I want to go into what's the OS look like, what's it based on, and what's it like interacting with this. So this is based on, the Lambda platform is based on, or it's not based on, but they publish an AMI that is available that you can go spin up an EC2 that runs the exact same thing. When it runs, it assumes an IAM role. So this is how we can get permissions to our thing. Just like a EC2 container, it gets a role, and most of us probably don't use roles. We just start up EC2 containers, but that is a way to attach permissions to a specific instance and not give it login credentials. You can run Lambdas in VPC, and when they do, they consume from your network space when they add elastic IPs to their interfaces so that they can talk to the internet. Again, very similar to the EC2. We noticed when the API is down for EC2, we can't launch Lambda. Like, Lambdas just don't work because it's required essentially to launch an EC2 to run a Lambda. That's just part of, just happens very fast in the background. And then inside, when you're running, it looks like you're inside of a normal EC2. If you're familiar with the metadata URL for EC2, that's actually blocked on Lambda, which I was surprised to see. Any EC2 that you have running, you can always hit this URL from inside the container, and it comes back with all sorts of metadata information, and what your IP is, what, you know, everything that you would be able to see in the console, but from inside the EC2, but they block it on this. So it's also very similar to Docker. You have a base container, you add your dependencies, and build this package. You have ephemeral local-only storage. I know Docker can mount in local volumes, but that still doesn't feel like a mature technology, so I'm going to lump along with that. Your fees are generally based on number of containers run, and each container has its own completely separate network stack. You should have hypervisor guaranteed resource management. I think they make that guarantee. And then, you know, between containers, like I can't see outside of my Lambda a Docker container unless you link the container to something else. So you really can't see any other containers. So I would just generally, we've been calling them micro containers, and that is the platform that makes it easy to know, is this the right technology? Well, if it's something small, yeah, we'll go run it in a Lambda. If not, we'll spin up a real Docker container for it. So why Python 2.7? This is that story. Red Hat Enterprise Linux is very conservative, based out of the RTP. I don't think that's why it's conservative, but their Red Hat Enterprise Linux comes with a 10-year life support cycle. That's probably why Amazon chose it for the basis for Amazon Linux. Even that life cycle you can extend. That was the basis for Amazon Linux. Lambdas run on Amazon Linux, hence we're using Python 2.7 for all Lambdas still. I think that may change in the future, but that's based on popularity going forward. But that's why it is the way it is today. So you can obviously call shell commands from Python. Someone had this great idea that you could, and you can also pass a payload to a Lambda directly from the Amazon command line interface. So you can pass a shell argument to a bash script. The bash script can call your Lambda over the CLI, and then you can remotely execute it and look and see what's going on inside the container. So we're going to run some remote commands on the container to look around. This was, again, not my idea, but I thought it was a great idea, and I had to go implement it as soon as I heard about it. So this is the Lambda itself. It's pretty simple. We're just going to call whatever we get passed in. We're not doing any validation or sanity checks because we're the only ones who can call this. Just going to call that, and then we're going to return a JSON back to our caller, and then we're going to look at the output on our local machine. This is the bash command, so it's going to call an eval. It's just essentially building this long command line string. You could do this in Boto 3, but it was quicker for me to prototype just using bash. And then we're going to use Python to decode the response object and print it. And I didn't know if the Wi-Fi was going to work, so I actually pre-did all these. But if you want to do one, just raise your hand and we'll run one. You can check the uptime of the machine. You can see where your current working directory is, where the code is deployed. If we check the file system, we see that we have half a gig of ephemeral space and temp to use. This again confirms, we're running AMI Linux based on Fedora, hence Red Hat is a big contributor to Fedora. They sponsor that project. We can look at the environment variables that are available, and there are many more that are probably platform specific that I trimmed out, but essentially you have your Python path, system path, you can get your region, may or may not be useful to you. You can look at the network and you can see that we're isolated away. We can't see whatever we're on. There's probably hundreds and hundreds of other concurrent processes, but we can only see what's going on with our own connection. We're hypervisor safe. Okay, so now we're going to explore the Python side of it. They all share a single function definition where you have two signatures. The first is your payload object. Second is your context object. The payload object can be anything that's really up to you to define, unless if you're connecting plumbing from Amazon, it's going to be whatever they pass you, and usually it's JSON. This is the very simplest, I guess, Lambda I could come up with is just return the response. Don't even look at it. So when you want to work with this, I would just say print this to the console, run it, just see what you get, or you don't have to even go in the interface. You can go look at the CloudWatch logs and see what the shape of the object is. So you know how to go traverse whatever JSON object is and get the parts out that you're interested in processing. The context object is a little more fixed, and it's going to be really important later in the CI side of this, so I wanted to go over it. It's also a dict. It's not printed as a dict because I couldn't get it on the slide, but the function version is pretty important, and here we have a special value called latest that I'll talk about later. And we have the invoked function ARN. This one is, because it's running latest, we don't have the full thing. If we were running a specific version, which is also going to come later, the version tag would be appended to the end, or the alias tag would be appended to the end, and those are going to both be important. But you have information about it, so yeah, your function, I don't know, if you had some function in your code that was being called from two different Lambda entry points and you weren't sure which one was buggy, you could look at the function name that was called and log it to see which one was misbehaving. Okay, so now we're going to take what we know about Lambda, we're going to package it up, get it ready for Docker so we can run it locally, and we can run it in CI and have the same thing happen in both places and be enterprise ready to run our application. So we're going to just cover how to make a driver script to run it locally. We're going to start with a shebang. We're going to import Boto3. One important thing is to set the Boto3 profile. So this is going to assume you've already set up your credentials, or you have some Amazon credentials to at least get started, set up on your local machine, so that when you call this, your Lambda can actually interact with the Amazon cloud. Otherwise, it's going to be like, I can't sign in. I don't have any authentication tokens. But we're going to set a default profile on Boto3 so that any subsequent Boto3 sessions are going to act as that session. So we don't have to pass credentials into our Lambda itself. Because whenever Lambda runs in the cloud, it's going to run as a role, which will also inherit permissions. So we don't ever want to check in specific permissions. You want to define a payload and context for your local invocations that are sort of similar, just enough to get your application running. Just totally duck type it, just put in the fields you need. We're either going to import our Lambda file, and then we're just going to invoke it. One thing you also need to do is go chmod it executable for your driver script. Otherwise, you're just going to have to type more. You'll have to type Python blah blah instead of just calling the script. So this is essentially just what we just covered. Very simple case. We're making an empty payload object. Context can be none in this case because our function isn't going to check it. The order is important with where we import here. I know this is non-standard from normally you put all your imports at the top and they follow a certain order and things like that, but if you don't do it in this order, it's not going to work. If you import your Lambda before you set your default profile, you will not be able to set your default profile because the Boto3 session will already exist and it will be defaulting to some other profile than you wanted. So just that's the order. Okay. Yes?
Is there a reason why the import and the session were commented about?
You don't necessarily need it. Like if you only have, if you are just starting doing this on your local machine and you've only you've only got one account in your Amazon account and you haven't set up like a Lambda specific role yet, you don't have to do those steps, because when it runs, it's going to wake up, it's going to look in your AWS configure folder, it's only going to find one set of credentials, it's going to use the default, and it's going to connect, and it's going to work fine. It's just later you're going to run into issues where it's not running locally with the same permissions as in the cloud, and we're going to come back and fix that. So that's why it's commented out. You can get started without those. Okay, so dependencies. The way we do this for our team is we use virtual environment. We started by just making a folder and checking everything into that folder, because essentially that's what you have to do when you deploy it, is just make everything available in the top of your, make an archive, put everything in the top of the archive, and it can see it because it's on the Python path. But that was a real pain once we had 7 or 8 dependencies, just having all these different folders of things. The versions, we weren't tracking the versions anymore. So we went ahead and set up virtual environments. We use pip, and we abstract out everything that we can. We keep our lambdas really thin so that all the logic and code gets tested as much separately, and there's just a little bit of integration testing that happens in the lambdas. And when we deploy, we take all of the packages and we flatten them out essentially the way that they were. So the archive has everything dumped in the top. But it's much nicer to develop using virtual environments. So that's what we do. We set up a virtual environment, or a requirements.txt. These two are really strange. Oh, well, Photo 3 is going to already be installed on your remote Lambda platform. Like, Amazon just supplies it, so you do not need to install it. PsychoPG2 is kind of a pain if you're on a Mac. It may not be if you're on Linux. We always use the OS to install that on our local, and then we do not make any reference to in our requirements, because it's binary incompatible between architectures. So you need to provide a different PsychoPG2 in the package that you ship to Amazon if you need to connect to Postgres. Versus locally, you'll have to have a different binary that can connect for the architecture that you're developing on. Yes?
Does this mean that for pretty much any C extension it won't work?
You're going to have to maintain 2 versions. You're going to have the one that your platform needs locally and the one that you need to run on AWS. I don't think it's going to be too much of a pain, because most of the common ones, people provide them as Git repos that you can just pull down and drop into your project. And that's probably what you do. But again, like when it runs locally, it needs to be outside the Python path, or Python's going to see that first in the path. And then it's going to be like, I don't know what to do because this token doesn't make sense for my operating system. So a little bit.
Can you comment more on how you guys go from your packages in your virtual environment to, actually in the folder in the bootloader that you ship to Amazon? I found that to be a real pain.
It is a real pain. And I've written a tool that does it, but I don't want to be like, here, go use my tool, because I think there's probably better ones out there. So you can certainly go look at mine and see how I implemented it. But it's essentially doing a bunch of balancing with pip, and then you rerun the pip, and you install. You just pass more flags to pip, and you say, okay, install it here, except for these 2 packages. If you see them, just ignore them and move on. Is how we flatten it out. But yeah, I think that part's kind of goofy. I wish we could just ship the virtual environment. So setting up the virtual environments, we script that too. This is a simplified version. Essentially, when they run it locally, if there is a virtual environment, it tears it down and then it creates a new one. So teams don't need to know all the flags about no-site packages, because we want to definitely do no-site packages, because then we run into that pain of, oops, I'm missing a library locally, instead of shipping it and finding out later. Then we source it, we pip install, and we're good to go once we activate it. All right, so next is operating system. This is where it gets crazy. The Lambda AMI is public, and you can turn an AMI into a Docker image. You can pull that image down, and you can run it locally. So essentially, you are running Lambda on your local machine as close as binary possible to being on the cloud. It sounds really hard. It's really not. The only big caveat here is once you take this executable off of Amazon, you can't run Yum, because you're not allowed to use their repos when you're not inside their IP space. So either script it so that you can repeat it and add packages that you need just to help you along, or set up an EC2 where you can pull that image up, put in the packages you need, and push that Docker image back to your own repo. That's another way to get around it, is just run it as a Docker inside Amazon. You can run the yum updates, push the image back to your repo, and then pull it down locally. Still kind of a pain, but this is essentially, we just do this for testing. We get a base image one time. We don't really want to modify what's in there, and then we go. This is the steps to do that. I think the only really weird one is the tar step. I look this up every time I need to do it on Stack Overflow or Stack Exchange. Yeah, 30 minutes end to end. And then the last step, make a Docker file, do the from wherever you've pushed your image for your Docker images, and then add your code in. You should be good. All right, next is permissions. This is where we're back into identity and access management with Amazon. So the concept is you have a policy in Amazon, and the policy is a JSON document, and we want to inherit from that policy both when we run locally and when we run on Lambda. So we're going to go into that. The policy document looks like this. It's a JSON document. Essentially, this one is giving access to logging, and it's giving access to 2 operations in the S3 commands. If you're accessing Redshift or not Redshift, but anything else that uses the Amazon credentials, you need to specify all of those into your policy document. And this is how we're going to inherit those permissions in the 2 places. Again, it's going to execute as a role in the cloud, and it's going to gain everything. It's one of the options for every Lambda is you specify the role to run as. You can have a different role for every Lambda. I think that's hard to manage. We generally just have one that has most of the permissions we need, and specify that one. If we have something that's elevated, we make a separate one off for those cases. But 90% of them all run as one role in the cloud, and then we all have access to the API keys to execute locally as that same user, as the user that has the same policy document. Again, this is just the steps. You'll have to install those credentials. You can also set them as environment variables. I always forget that. You can inject them into the environment, and Boto 3 will just see them as soon as it starts up, so that's even easier than trying to specify a profile. In the order of dependency, that is the first one that it will see by default. Even if you have AWS default credentials, it will see the environment variables first. It's the same thing for, I think it's a little easier for the role. All right, and then finally, VPC security groups. This is tricky because you really can't fake this locally. This is the permissions at the network layer between assets that talk in the cloud. You need a way to tell, you're just not going to be able to tell from CI if your VPC configuration is good. So you need a way to tell, is my infrastructure broken or is my code broken? So we use a Canary Lambda that doesn't really do anything except just wake up, talk to services, and report who it was able to talk to successfully and who it couldn't. And that's all it does. And then we can run it in each environment. We can see, okay, it's working for developers that are VPCing in, it's working for the CI server, or it's not, and it's working in the cloud. This is just an example of how we run that. We can just look at the CloudWatch. I mean, you could do fancier error handling here, but usually we're running this manually just to see what's going on. And so a print statement's enough because we're going to directly look at the log file to see what's going on. All right, so we've got everything now packaged and consistent with the way it runs on Lambda. So we're ready to test because this beautiful container that we just created can also just go run on our CI server. Again, keep everything as thin as possible. I think it's easier to abstract out your tests, run them in the normal way that you do in your Python libraries, versus having these integration level tests where a lot of things can fail. And you can install your own Git repos. It's a little bit wonky with but this just drops into the requirements.txt. This will tell pip, I want to use this repo. I want to use it as a Git repo. I want it to be editable. It puts it in a different directory when you do that. So it will be in your project and editable, and you can push back changes instead of having to switch projects. Okay, I think the graphic's going to explain this better. So we have our CI server runs and deploys the image. After it's done with the deployment, it expects as a construct in all of our containers, and this is just you set up whatever expectation pattern that you want. But in the root of the container, there's going to be a file called test runner that's going to call nose and copy the results back for us. And that's all the CI server needs to know to be loosely coupled with the Docker image. So that test runner is going to wake up. It's going to be in the root file system. It's going to know where the tests are inside this container because we check it into the same repo. It's going to run our tests. It's going to know what to do in nose from the setup.cfg. That's where your code coverage expectations and where to find the test files that are going to be all in the setup.cfg. It's also going to specify that we need a junit.out so that our CI server can process which test passed and which didn't. At the conclusion, it will copy that. The test runner will wait for the test to finish, look at the return code, and it'll copy the JUnit file back to the root of the file system, and the CI server will go to the next instruction when the prior one's done, and it does another docker run command to copy the JUnit out to the workspace on the CI server, and then I can parse it and see, did the build pass or not. If you're doing something with like Circle CI or Travis, I'm not sure quite what the steps are for that, but this is how we run Bamboo, and so we just write bash scripts for what we need to do on CI. And this is how we test our Docker containers. Okay, so we got testing down. Next is environments. So these are more things specific about Lambda, how to manage having dev stage prod once you've got your first version working locally, manage having your Lambda talk to the right one, detecting which environment it's running in. So first, you guys probably have some construct similar to dev stage prod, local, or maybe you have a subset of those, or maybe you even have more of those where you have a QA or something else like this. In the past, we would have set this as an environment variable for our applications to be able to detect, oh, I look at this environment variable, I know the environment that I'm running in. Since we can't do that here, Lambda needs to detect it. So one way we can do that is using the alias that the Lambda is run under. Another way we can look is at the event itself and see if the bucket name, like if you have a separate bucket for dev stage prod, you can look at a substring of that string to see which environment you're in. You can also look at the payload object itself if you're doing something like a data pipeline where the file data that you're going to actually parse has that value in the JSON that you're going to look at. I think the alias is the best one by far because that works for all situations. You don't have to worry about what kind of objects you're looking at. You don't have to look in different places depending on what you're doing because you always have the alias if you set your lambdas up that way. So a version is when you take the latest version of your Lambda and the latest version of the config, and it makes this artifact from it that, a mutable artifact, and it just gives it a number. So it's, when you sign into the console, you'll have multiple versions. Like if you don't create a version, you can keep changing your code. It never makes a version. But if you tell the platform to make a version, it says, okay, I'm going to take the current code and the current config. I'm going to make this object. Forever after, you can refer to this thing as version 1. You can't delete it. It just exists forever. So we have we test with our Chatops bot that we can deploy pretty regularly. So this Lambda has 55 versions, plus the latest version. Anyway, this is just showing how it would appear in the AWS console for those 55 versions. You can call your function with any of those 55 if you subscribe them to an event stream, and whatever different versions, they're all maintained there. So this gives us some flexibility to have dev stage and prod, although we wouldn't want to do it with managing numbers. So fortunately, there's this construct of aliases that lets you point a tag to a specific version. Now you have this nice abstraction of where you want each one to point. And they just referenced a version for us. So that lets us do things like this, where we have 3 concurrent tiers of data moving through. And when we get the S3 event, because we're going to detect from the alias what environment we're in, so we know when we wake up which credential set to go use, which database to go talk to, and where we're getting the data from. This lets us just decouple from what's going on with whatever we're receiving. You can have multiple tags point at the same version. So if you've written some code and put it in your dev version and everything's great, you can now promote it to prod. All those tags will point at the same place, and you'll still have your data go to separate places. You don't have to check in, oh, I'm a dev version and I'm going to point at this database. So I'm recommending that you use the aliases as the way to manage which environment you're in, and not check in anything specific to an environment in your Lambda about, I'm at this one, talk to this environment. Second, I'm going to recommend that you keep all of your credentials for things that you can't do via the IAM role in S3, because if you had to go redeploy your code because you changed the password, it would be kind of a pain to go redeploy our Lambdas. The pattern we use is our Lambdas wake up. If they need to connect to one of those things, they go get the credentials out of S3, a key-wrapped credential set. In that YAML file, there'll be a section for each environment that it needs to talk to, and it will get the right credential set it needs to talk to and make the connection. Is that clear? That's...
You mean you put like a basket of environment variables there? All your config is in an S3 file?
So if we have 3 Redshift clusters, we'll have a heading called dev, stage, and prod. And each one we will have all the connection information that you need to connect. So it'll have the server name, it'll have the server port, it'll have the username and password in that section where they all have the same tag. So when the Lambda wakes up, it says, oh, I'm a dev instance, go get the dev Redshift connection, and it comes back with that Redshift connection with the right credential set and makes the connection. Whoops. Yeah, so the KMS service here, we're using key wrapping. To get started, you obviously don't have to do that. Key wrapping is a separate topic, but essentially you can set up an S3 bucket that will not accept anything unless it's encrypted using your key, and it encrypts it at rest. So that's how we maintain the security. So I will make that credential set on my local machine. I will specify the header when I upload the file that it has to be encrypted, or to use my key. I put it in the bucket, and then I can specify to an IAM role if it's allowed to use that key. It will transparently decrypt those to anyone that requests that object from the S3 bucket. I think it's a pretty neat service, although we're not using a ton of it, but that's how it works. So essentially it does the encryption for you if you're allowed to, but it's all transparent to the user. Let's see, got a couple minutes. So this is how our workflow is for local developers. They work locally, they check in, the tests run when they check in. If they pass, then they can deploy to dev or something like that. They can go out and validate and then promote. Like, that's pretty similar to what they would do for traditional. It's doing Lambda. We try to make it similar to that pattern because that's what they're used to. One way you can do this is just hook it to that post commit hook and move the dev alias. Like our chatbot actually does this for us, and does this for us, and these are the steps that he does when you ask him to deploy. We do it ad hoc, and this is the URL for if you're wanting to flatten out your Lambdas to deploy them in S3. It also has the code that does the deployment. But yeah, this shell script is handled by our chatbot. And then same thing with promoting. This is really quick. There's not much to it. You're just moving a pointer, so it connects to the API, moves the pointer forward. These are our Chatops contracts. Okay, so finally, one thing that Amazon really stresses is like this whole high availability thing and designing for high availability. We're big enough that we don't have 100% uptime of, there's always something broken. That's just part of how things are. But we've had 2 outages since we set up Lambda, despite following all their policies of, okay, set up everything in multiple availability zones in your account. And what I found out since then is availability zones are fake, at least the way you thought they were. They load balance these as they choose to. If you have multiple accounts, they don't necessarily point to the same one as between accounts. So if you think you're locating things in the same zone, because you're like, oh, well, we have 2 accounts in our business, and we'll put these both in US 1A. Sorry, they're not. Probably not anyway. And I'm not even positive that all of them are real. I think that sometimes if they're short on space, they will put like 2 different zones at the same address. These are fake addresses, by the way, but this is how it works. And they do state that this is what they do to load balance demand in different data centers. Otherwise, it'd be very hard to have like every building scale exactly the same for capacity. So what we do is we co-locate our Lambdas at the region level. When you think about it, this is pretty cool because you get free infrastructure. You don't pay unless you use these things. So I can put these in every region that I'm allowed to. Doesn't cost me anything. They're ready to go. They're hot. And then if something happens where a zone goes down, I just go update my API gateway configs, and everything falls over to another zone, and off we go. So it handles it. I have not seen multiple regions go down at the same time. So this is the pattern I'm recommending if you were like, I need really high availability for this. And then for managing your API contracts, if you're getting into API gateway, that is not a great, it's kind of confusing. I would say go check out Swagger because I think that can wrap it up and connect to it, and it can do the whole connection between your API gateway and Lambda for you. All right, questions? Yes?
Can you elaborate on what's the initial reason that make you decide to use Lambda, and what's the competitive tools in the market?
It sounded really cool, and they were pushing it probably at AWS last year. They were essentially like giving out those Alexa devices if you like go write a skill, and they had like a hackathon to go write skills. And I did that. I thought it was pretty neat. But for some reason, the serverless thing is really appealing to devs, and they're all like, oh yeah, I want to try that. That's the main reason. But it's also, there's a lot of cases where it's like, I need to do this little task every day at a certain time, but it's going to cost me a minimum of $27 a month to bring up like a T2 Nano that's dedicated to this one task. But we're like an all Docker situation now, so it's like, I can either run a Docker, I guess, or I can just have this one thing separate. Because some things need to run outside Docker, like they're like things that watch Docker generally don't run in Docker. So we just have, there's just little needs for things here and there, especially things with inside the cloud. I think it's super useful for like DevOps in the cloud to set up user accounts, things like that. Like I can just set up a web front end for it. They can make a form, I can OAuth them, and then it can just create their Amazon account for them, things like that.
Any competitors you're aware of?
There are other competitors. I know Google has one, and I haven't.
Can you repeat the question?
Okay, so she asked if there's competitors in the marketplace. I'm pretty sure that Google has one, and I haven't used it. But that's as far as I know. I would suspect that Microsoft has one or is coming out with one because this has gotten a lot of attention, maybe not a lot of money, but yeah. Yes?
What kind of events, so I know that these Lambdas are fired off in response to events. And
Yes.
I know things like an inbound web request could be an event, but what are some other events that these things can trigger?
The biggest one for us was S3 generates an event when you drop a file on disk. And we have our ETL pipeline connected to Kinesis or Firehose. So it drops things in S3 for us. So we just subscribe to that event stream of dropped messages. Those generate events. You can subscribe them to an SQS queue. Or I'm sorry, not SQS, SNS queue. So anytime there's an SNS message in the queue, like the Lambdas will pull it off and process it. cron can generate the events as well. Like they have cron scheduling where you go specify either in legacy cron format of like when you want something to run, or you say daily, something else similar, like I want this to run once an hour or once a minute. It will generate that event and it will get processed on Lambda. There's like 7 or 8 different things.
Have you done anything around aggregating your logs? It's kind of a pain to go like day by day.
Yes.
By Lambda, and also related to that dashboard for monitoring either Amazon's or events.
Yes. So we are not monitoring Lambda yet, but we are using Rollbar for most of our aggregate logging. That is the platform that our teams have been like, we like this. They're a sponsor. Go figure. So yeah, that is a thing we're looking at. And we actually use Lambdas to monitor Lambda logs in some cases. There's something called CloudTrail that you can turn on for free in your account. You get 1 copy of everything that happens in your account via any API interaction. It just logs it in there. And we use Lambdas. And so then they drop those logs in S3, and we subscribe to that stream and then process it. But it includes like Lambda events. So, but also other neat stuff. Like that's how we check if someone made a new IAM account and we want to see if it was something we want to allow or not, or if we need to go have a conversation. We subscribe to that and look for those events.
Please, let's thank our speaker and thank you for